All right, AP Computer Science students, we're going to try something a little different. This is something I've meant to do for a long time, and because I'm going to be out of the school here on November 1st, I figured this would be a good opportunity to try it out. I'm going to conduct a lecture by recording, and I've never done this before, but we're going to give it our best shot, and we're going to see what happens. You have in front of you the warm-up. I would say 2.5 minutes is a good amount of time to try and attempt this warm-up. Let me caution you, I'm throwing some new things at you, and I want to draw your attention to that. We're declaring a string S, which hopefully you see on the screen now. But I'm also using some methods that we've talked about, but I want to remind you what they do. The contains method is a method of the string class which returns true or false whether or not the string contains the parameter you're looking for. So we're asking, does S dot contain the string literal E? The next thing we're bringing up is substring. So recall that substring is a method that we use that returns a portion of a string. It can have two parameters so that you're getting the values between those parameters. Or it can have one parameter where you are substringing from that index onto the rest of the string. And then last but not least is index of, which you also see in the body of the for loop there. Index of returns the location of the first occurrence of the thing that you're looking for. So I'm going to ask the sub to pause the video here and give you 2.5 minutes. Make some notes in your notebooks. Remember, we're going to go screens off. There should be no screens on at the room at this time. And make some notes in your notebook. See if you can figure out what it is that this program does. I will pause so that the sub can pause for 2.5 minutes. Okay, I'm back. Hopefully, here's what you determined, is that this is a for loop whose job it is to remove all the e's from that string. So let's walk through it a little bit. You've got the for loop in I equals 0, S dot contains E, I++. And what that means is that we initialize I to 0, and then we check to see if E appears in that string. And sure enough, in the word reluctantly, there it is, so it's true. So we head to the body of the for loop. We check what the index of E is. The index of that first E is 1, right? We're 0 indexed, so R is an index of 0, and that first E is an index of 1. And then we substring from 0 to 1, and we connect that from a substring from 2 to the end of the index. So it takes the R, and then it takes reluctantly crouched at the starting line, and it connects it together. So it's essentially chopped out the first E, and then it'll print that out. Then we go back to the for loop. We say, does S still contain E? It does, and we remove the next E. And then we go back to the for loop. Does it? We remove the next E. This time it's the E in the. We do it one more time for the E in line, and then when it's all said and done, the string S had all of its E's removed. It was a way of snipping out all the E's. Very clever, very challenging. It's something we can talk about when I get back on Wednesday. All right, so we begin chapter 4 today on conditional execution. If you want to make sure your notebook is out, you can label this 4.1. It's something that I'm jokingly calling if true, then do. And it's a way to design your program so it can take into account different possibilities. If you're in this scenario program, I want you to do this. Otherwise, I'd like you to do that, so on and so forth. This is actually true of Monday, so there's 181 days until the AP Computer Science exam. We've got 4 goals for today. We're going to learn about if statements and relational operators. We're going to learn how to use and, or, and not. And we're going to compute some Boolean expressions. So we're going to leave this up on the screen for a minute. I want you to look at this snippet of code and see if you can find the logical error. I'm going to ask the sub to pause the screen here for a couple of minutes. And let's see if you can figure out there is at least one logical problem with this snippet of code. Okay, so hopefully we figured out one of two things. First of all, if we were trying to break this code, and I should have explained this before the pause, but this is a a method whose job it is to withdraw an amount from a bank account. The purpose is to when you go to an ATM, take a little bit of cash out, right? Well, what if the cash that somebody inputs, they put in a negative amount? You could say, I'd like to withdraw negative $1,000, and all that will do is add $1,000 to your bank account. So there's one flaw. Here's the other flaw. Let's say I only have $5 in my account, and I want to deduct $1,000. There's nothing stopping me. It's just going to say that the balance in my account would be negative $995, and the ATM would pay out $1,000. So it's obviously a lousy program. How can we fix it? The answer is the if statement. So I'll give you a moment to pause to write down this basic syntax. If, then, excuse me, if there's a test expression, then we put down that statement, and it can logically be explained as you see on the right, where if something is true, then you're going to execute this other piece of code. If it's not true, you're just going to continue on otherwise. So here's how we could use an if statement to fix at least one of our logical problems. We could say, if the balance is greater than the amount you're trying to reduce, then go ahead and deduct that balance and post what the new balance is. All right, so that would be one way to fix it. So how does this make sense? Where have we seen relational expressions before? So we've seen actually some of these things in for loops. If you look at the second component of a for loop is always the relational expression. We're checking to see, is I less than 5? It's something that evaluates to either true or false. Well, this is true in the body of an if statement, or excuse me, in the test of an if statement. Say I was making a video game. If my hero had hit points less than or equal to 0, we would say that the hero has died, and that would be very sad. So we've seen this before a little bit. We're going to be using it more in the future. Here's a table of relational operators. No need to copy this down. I just want to point it out. It is in your textbook. These are the 6 relational operators we're going to use most often. You can see them here on the screen. We're going to skip past it because you've seen it before. I just wanted to remind us all. I want to make a note about confusing equals equals with equals. So when I say equals equals, what I'm really asking is if a value is equal to a certain amount. I'm going to check to see if age equals 17. Whereas if I do 1 equals, I'm not doing a check, a relational operation. I'm making an assignment. I'm setting the value of 17 to the variable age. And that's a problem because if wants to know if age equals 17, it doesn't want age set to 17. And an example of this might be, say you were going to the movie theaters, to the box office. You wanted to see a rated R movie like Deadpool, which is gross and awesome. You would, the ticket taker should check, hey, is your age 17 or greater? Really, the logic check should be if age is greater than or equal to 17. But for the sake of this slide, let's say they're going to check to see if you're 17. If instead I were to say age gets 17, and that's the different word I'm going to use. If I use 1 equals, I'll say gets to show that we are assigning a value. That's like the hit Zac Efron movie, 17 again, where I'm not checking to see if somebody's age is 17. I am making that person's age 17. And we don't want that at all in any way. So just remember, when you see equals equals, say equals out loud. When you see 1 equals, say gets or assigns to show that you understand we're not doing a relational check. All right, so here's the big new idea for the day. Take a moment, certainly copy down these 2 symbols here in the left-hand column. It's the AND operator and the OR operator. And it's a way to make sure that you can check 2 relational expressions. So I might say, is this true and that true? Or I could say, is this true or that is true? And they work a little bit differently. For AND to work, both your first and your second relation must be true. I see here 2 equals 3 is false. -1 is less than 5 is true. True and false evaluates to false. In order for AND to work, it must have evaluated to true and true. All right, similarly down here for OR, we've got this exact same expression, but this time it's false or true. And OR just needs 1 of the expressions to be true. And so that one evaluates to true. And then not, which is the exclamation point, which we sometimes call bang, not is something that just flips the value. So 2 equals 3 is false. and then not flips the value to true. That's how that works. All right, here's a funny slide for Boolean hair logic. The way it works is I have a guy who is Mr. A and a guy who is Mr. B. And the and guy has all the facial features of both A and B. He's got the widow's peak and the sideburns, but nothing else because that's their only overlap. The or guy has everything that they both have. So he's got the beard, the goatee, the widow's peak, the whole 9 yards, right? XOR is something we don't use in this class, but it's a part of the funny comment. It stands for exclusive OR. It's only the parts that one guy has, but the other guy does not. So we only do and or in this class. So for practicing evaluating expressions, 3 not equal to 5, I'll give you a minute to figure that out. And the answer is that one is true, right? Because 3 is not equal to 5. When we check 14 greater than or equal to 14, that evaluates to true. 10 less than 9 is false, so true or false. True and false evaluates to false. Then we have 10 equals 13, that is false, or 450 greater than negative 13, that is true. False or true evaluates to true. 100 equals 100, that is true. 13 is not equal to 7, that is true. Negative 3 is greater than negative 4, that is true. True and true evaluates to true. Let's talk about short circuiting for a minute. So Java knows how to cut corners sometimes when it'll help on computing power, and one way it does it is through short circuiting. If I say true or and then some other, I'm recording this during lunch, can you tell? If I say true or some other expression, that is always going to be true. It doesn't matter if the second part is true or false because or just requires one true to be true. It short circuits and it won't evaluate what comes after this or as long as they're just two relational expressions connected. Similarly, false and always short circuits to false. There's nothing I can put here that will make this evaluate to true, right? So there's that. That's short circuiting. Here are some truth tables when P is true and Q is true. How does P and Q work? How does P or Q work? These slides are all posted online already, so you can come back and look at this truth table later. But here's a visual representation of how and or work. Relational expressions are evaluated from left to right. So the way it works is, and it happens last. It happens after parentheses, multiplication, modulus, division, addition, and subtraction. So the way to think about it is when we revise PEMDAS, logical operators come at the very end. Logical operators come at the very end. They can't be chained like in algebra. You know, in algebra, we can say 2 is less than or equal to x, which is less than or equal to 10. This breaks in Java. This is really two different relations, and we have to check it that way. So we say 2 less than or equal to x, and is x less than or equal to 10? And this is the way that we would check a compound inequality in Java. All right, so I'm going to have the teacher leave this slide up for another minute and a half. Practice this. Let's see if we can get these 3. I'll give you your minute and a half. Starts right now. All right, we're going to skip that. And here is some classwork. We're going to go ahead and start on this. I'm sure you have, gosh, it's block day, so you have at least an hour. Go ahead and start on these self-checks here. This is where we ended in first and third period. There is a longer list of self-checks and practices. For the remainder of this period, you should be getting as many self-checks and practices done. There's no quiz this week, no self-checks this week, and no practice slips due this week. But there is a big practice it slip that's due the week after this one. So you're going to want to get as big a head start as possible. I'm going to be introducing a new weekly project on Wednesday that'll be due early next week. So get this done as much as possible. You're not to work on other classwork until you have all the self-checks done. And you're not to play games. Don't mistreat the sub. Let's stay on task. And thank you very much, and I'll see you all Wednesday.